Okay, the recording started. All right, so this is week 5, day 2. On this day, we'll be doing the review for exam 1. Exam is on Friday, as I said before. I do have 3 problems for practice. Yeah, for exam preparation practice. Okay, I'll send the question if it needs to be sent somewhere, but um, if it has like 2 question, I haven't decided yet, like whether it does have 2 sections or 1 sections. Most likely it will have 2 sections, okay, because always it's not enough time to deal with 3 problems or more problems in class. So there are like 3 problems, obviously, right? We're going to do practice, and all 3 problems are from chapter 12. That's something that you have done already, like the similar problem. As you can see, the first problem is the very same problem we did in last class. Remember, there are the rope attachment and everything, and there's this homework related with this one already in Brightspace. Okay, just to give you a heads up, and that homework is due on Friday as well. Okay, so the first homework, without further ado, you remember the main concept for this kind of rope setup is find somehow the total length of the rope. You guys remember that, right? So you got to find the rope length. Once you have the rope length divided in different segment of pulley, like here, this is one segment, this is another segment, this is another segment, this is another segment, this is another segment, right? If you can divide them and kind of add them up together and can write the total length of the rope and then do the derivative with respect to time t, which is going to give you the velocity equation, and then do derivative one more time to find the, to do derivative of velocity, what do you find? Acceleration. Okay, so that much is straightforward. So first thing, the difficult part for this kind of problem is to figure out the different section length of the rope. Okay, because you see there's these 3 pulleys here, some are fixed, some are hanging. So like the top one is fixed, these 2 are hanging, so these 2 changes all the time, right? Does that make sense? So because those 2 changes, this length here on different part of the rope we're going to change as well. Okay, so that's what the challenge lies here. And obviously they ask you to find I think on this one they ask you to find the velocity for this block, where they give you the velocity for this block. Okay, there are 2 blocks here, A and B. So they give you the velocity for block A, they are asking to find the velocity of block B. All right, let me get my class note, just 1 second. All right, as I'm saying, the biggest challenge would be for you to figure out different section, right? So let's focus on that. You see, since this one is B, what you can do, this is the block B, right? What you can do when you name like different section of the rope from top to this first pulley. If you're gonna say this is your pulley number 1, this is your pulley number 2, this is your pulley number 3. So just for naming purpose itself, right? You can say this is as B. Now there is another portion of the pulley here, which I don't like to say is the rope. This one. What do you think this is? Is this a rope? It is kind of a rope chain or something, but not related anyhow with the main rope, right? You see, right, Joe? The one that extending, it doesn't have any relationship with the main rope, right? The rope that start from this point. It makes sense? All right. So then we now understand what is SB, and SB, the name comes from the block B. Okay, but there's this thing here. Let me highlight that. So this portion here, right? This is the rope, right? For sure. So this portion can be written as SB and SC. Okay. If you're gonna say this one is C. Okay. And this one is SA. Okay. And this one can be say as A as B minus SC. Now I gotta define SC, don't worry. Let me do that. SC would be this is my SB and this is my SC. Okay, see if you understand this. Let me try to do some color code. So this line here, SC. Okay, this is for C. SB is this line. Okay, let's do some more color code. So this SB minus SC is this line. Okay, now you may see it better. SB, SC, you can say SA, the other one. Do you guys agree? Joe, you understand? So this SB, which one is SB, which one is SC, which one is SA, which one is SB minus SC? So this is the challenging part. If you're gonna see this kind of problem in exam, then don't get scared. You just have to figure it out, different length of this rope. Okay. So now you have this two rope here. Do you guys agree? How many ropes here? There are two ropes, right? Okay, so let's see if I can highlight one of the ropes. So this is the rope 1. Right? Brad, is this rope 1? And is there another rope here? Which would be, let me see if I can do it in different color. This is the rope 2. Ramsey got it? So this is my rope 2, right? All right, now we have two rope. So rope 1 and rope 2. For those two rope, we have two equation. Okay, for rope 1, we have this SB plus SB minus SC equal L1. Do you guys agree? All right, for rope 2, can I write SA plus 2 times SC L2? That one is tricky to understand why it is 2SC. Everybody can see that? The color code and everything? All right. So now you have those both rope. What do you want to do? Your goal is to make life simpler. You see, you are given with the VA. V has something to do with SA, right? And you are asked to find the VV. VV has something to do with SB, right? So if you can find a relationship with SA and SB and somehow take out the SC, if you can do that, follow me what I'm saying. Okay, Joe, you have these two equations. On those two equations, in the left side, you have SA, SB, and SC, right? So if you can somehow take out SC and find a relationship with SA and SB, you know what is SA, SB, right? Two part of the rope. You're seeing it here, right? This is SB and this is SA. If you can find a relationship for those two only, then you can differentiate it with respect to time t and find a velocity relationship with those two. Does it make sense? And you are given with one of the velocity. The other velocity, can you find it? If you're gonna get a relationship, right? Have you understand what I'm saying? So you have just two equations. Somehow you're gonna throw out the SC. How are you gonna do that? Answer. Take a look on these two equations. You see, you have this 2SC here on the left side, right? on the top equation, you have just one SC. If you're gonna just add them up with multiplying 2 for equation number 1, if you say the first one is equation number 1, multiplying equation 2 with equation 1, then you will have 2 times SC, right? And add them up, this SC and 2SC and 2SC are gonna go out. Does that make sense? And that's how we're gonna find the relationship with SA and SB. So let me do it. So like this is my equation number 1. This is my equation number 2. I can write equation 1, okay, multiply 2 plus equation 2, and then I'll have 2SB plus 2 multiplied SB minus SC, 2 multiplied L. Before I do the equal sign, let me do the other one, plus SA plus 2SC equal 2 multiplied L1 plus L2. Does everybody understand this? This algebra. Do you understand the algebra? I'm just multiplying the first one with 2 and then just simply add them up. Does it make sense? Take your time. Let me know. But we have 2 more problems also. So let me know faster. Okay. Everybody understand? Agree? If you understand that, then the problem is done, literally. Because, you see, this SC and this 2SC and this S multiplied 2SC are going to go out. So we're going to have 2SB plus 2SB again plus SA equal 2L1 plus L2. You're going to write it like 4SB, right? SA 2L1 plus L2. Now, can I do derivative with respect to time t in both sides? Can I do that? I can literally do anything, but this is what I can do for sure, right? So on the right side, if I'm going to do the derivative with respect to time t with a constant, what the derivative knowledge tells you from last class? The value would be 0, right? So there won't be any value for if you are, because the length of the rope that won't be changing, right? L1 and L2. So this would be 0 for sure. So the whole thing is 0. And then you'll be left with this d by dt 4SB plus d by dt SA. Now can I write this as like 4 VB plus VA equals 0? You know dV by dt is V, right? Sorry, ds by dt is V, right? The velocity. Derivative of position with respect to time t is the velocity. We know that, right? So then, if you know the VA, can you find the VB? What is given? Is V or VB? VA is given. It's like 4, right? So you know this is 4. This is VB 4. So VB should be minus 4 by 4. This is meter per second, by the way. So minus 1 meter per second. This is what I hate to do overriding. A little bit less overriding now. Let me try to make it even better. So minus 1. Putting a box around it. Okay. Any question? To give you a wrap up, we have 2 different ropes. Already write the rope equation, add them up, do some algebra, take out the SC, and do a derivative to find the SA and SB relationship. And then finally, after the derivative, we have the VAVV relationship. We know one of them. We can simplify the other. If you have any question, raise your hand. If you don't, then I'll just simply move on the next one. Okay. Next one would be something to do with the normal and tangential velocity and acceleration. Normal and tangential acceleration. I'm sorry, what am I saying? Normal and tangential acceleration. How many of you remember the equations for normal and tangential
acceleration relationship. You do it, right? So we'll just simply apply that here. So let's read through the problem. Before I do that, let me wait a little bit. I'm seeing still some of you are writing, so finish the writing, okay? We know when I should be moving on. Okay, the second problem is so important. You'll be seeing similar problem in exam, okay? Very, very important. All right. So starting from rest, the motorbike travel, you are not seeing it. Let's say you're done. Okay. So this is the problem, right? So starting from the rest. Oh, by the way, you're gonna have the video record on Brightspace in case if you. I mean, that's what I'm saying. Like you don't have to write the whole question or anything, right? You know. And all this material, I believe I uploaded it already. Chapter 12, everything is there in Brightspace. Okay. There are more materials, even what I'm covering here, just to give you a reference. Okay, starting from the rest, the motorboats travel around the circular path where the circular path radius is given. They call this thing radius or radius of curvature? Radius of curvature, right? At a speed where the velocity of this boat here, the motorboat is given. The speed is related with some equation. By the way, I am not solving it in engineering format. I'll be expecting you to solve it in engineering format if I ask you to do so. In exam, if it's in class, maybe not, but in take home, always, if there is a take home portion, give you a heads up, okay? You're going to lose point if you don't do engineering format. All right. So what time is t is the time, right? Time is in second, obviously it's given. And again, you understand the v, the velocity, that is the velocity of this boat, right? The motorboat, okay, is traveling around a circular path. It's quite common, right? People do it for fun. It's a fun. So, I mean, especially with the jet ski. How many of you ride jet ski before? All of you? I did once in the sea. Did anybody ever did it in sea? Okay, how high it go? I remember one or two stories at least, depending where you're doing it. Anyway, so okay, so yeah, I have this velocity with the t relationship, right? The t is obviously in second. You know that. Determine the magnitude of the boat's velocity and acceleration when it travels 20 meters. Now here is the clue. They said the boat start from the rest. Now you may say the boat may start from here, the s equal to s0 equal to 0 here, right? You can say it doesn't really matter where it starts. It may start from here, right? Even though there is no water is showing, but assume there is water here everywhere. So it doesn't really matter. Assume the boat starts from there. When it starts, it does have a velocity though. The velocity is v equal to 0.8 t. Now you have to understand the t here is 0 when it starts. So the velocity would be 0 obviously. But slowly the t will gonna, because with the time the velocity get increased, right? So you're gonna have the acceleration. You have the idea in mind, right? Because when the time passed, more and more velocity, so more acceleration. So it's a linear increment. So the acceleration would be constant, okay? Just to give you another idea. But there's the acceleration here, right? And that's for the linear acceleration. But again, you have to understand the boat has a circular path. Whenever the boat has a circular path, it has two different kinds of acceleration. What are those? Normal and tangential. Do you remember the equation for the tangential and normal? So the normal one would be, the normal one would be dv over dt, right? And the tangential one would be v square over rho. You guys remember that equation? Everyone? So let's focus now. Again, what they're asking. They're asking two things. Determine the magnitude of the boat's velocity and the acceleration. So they're asking two things. They're asking the velocity. They're asking the velocity at the distance as equal 20 meters, right? They are also asking the acceleration. So these are the two things they are asking. And again, as I said, because time limitation, I don't have time to do the engineering format. Everyone understand the problem? All right. So now we have the clues and equations and everything. Now the bottleneck or the problem here is the t. We don't know the t. If we don't know the t, then finding any of the thing is difficult. If you know the t, then after it travels 20 meters,
we can simply plug the value of the t and then find the velocity. We are done in the first part. The second part, we can easily plug the velocity, we can find the a, and right, rho we know already 50 meter. And we can do the derivative one more time and plug the value of the t again if there is any t left, right? And then basically we can solve it, right? Means the acceleration, even though I have these two components, it can be found by doing the Pythagorean, which is an square at square. You know that, right? You have done it several times already. So the problem is finding the t. So that's the question: how do we find the t? Okay, that's what we're going to solve. That's the biggest challenge. All right, so let's just focus on that then. So if we're going to write that equation of velocity, that's the solution, right? If you're going to write the equation of velocity, can I write it? It is ds over dt. And by the way, you have s0 equal to 0, right? I don't want to write it next to it, so you're not going to get confused. At time t equal to 0, or at rest position, you assumed, that's your assumptions only, s0 equal to 0 meter, right? You assume that. So as if like you're assuming your s0 is 0 meter here, and it's asking, did you see the path that I'm following? It's asking, say like here, s equal to 20 meter, right? That car path, not necessarily the straight path or anything, right? So they're asking, they didn't ask you directly. You gotta find how long it takes for the boat to travel that 20 meter. You understand? All right, so far I jotted out everything in a perfect way. So now we are ready. Now this is the velocity question, right? Now what do you want to do? I mean, what should be your clue? To find the t, your clue should be, as you know, as just somehow do the separation of variable. Just one second. Somehow do the separation of variable on this equation and move the t on the left side, right? And keep the s on the right side. Why? Because you see the v is a function of t, right? I'll just simply plug v equal 0.8t. And then you can do the integration on the left side. And the right side, you can do the integration again for s, but you know the s, initial and final s. So right side is already known, right? If you do the integration, left side is the challenge, right, Joe? Because left side you got to do integration for 0.8t, right? And again, you don't know the t. Since the right side is known, somehow if you're going to get a left side equation in terms of t, then you can find the value of the t. Do you understand? Do you understand? This one is a little tricky. So I'm saying do the integration in both sides, and I'm saying, put the limit on both sides as well. 0 to t, initially t equal to 0, right? And then I'm saying, okay, then plug the value of v in terms of t, because it's a function of t, right? And I'm saying just write it is s minus s0. How many of you understand this? That I can write, should be, right? How many times you did it? If not 100 times, at least 10, 20 times, okay? The same thing that what I just wrote. Okay, so hoping now you started to get it, right? Or remember it at least. Okay, see the arrow? You know what does it mean? It means like I'm going from the bottom to top again, right? All right, so then I have this 0.8, nothing to do with the integration, just simply taking it out, 0 to t dt, and then I have the s0 is 0, right? I know this is 0, so I have s, and I know the s value is 20, right? Okay, before I plug the value of the 20, let's do a little bit more. How did I do that? In case if you're wondering, if you have 0 to t, right? It says there's a limit 0.8. I have this t square over 2, the same thing I'm writing. And then remember, what did you learn in intro to engineering class? Don't plug any values before you have the final form of the equation, right? So you have this t square. I hope I did it right. I'm not taking a look on the class note. Yep, I did it. I think I'm doing it right. So, okay, so I have this s, so 2s divided by 0.8, right? So the t should be equal 2 multiplied s 0.8, right? So 2 multiplied 20 divided by 0.8. And the t value, if you're going to do the math, you're going to come up with, 7.071 second.
right? Is that the value? I mean, this S may confuse you. You want to put it SEC second, okay? If it confuses you. Or there's another way. You can write it for unit. Always you want to write it this way, right? With a bracket. Everyone's familiar with that? I'm just saying like this S can confuse you with the position S, right? Right, Joe? We use the S for position. So yeah, that could be, okay. So now that you have the T, let's see if you can find the solution of the problem. What you are after, by the way? We are after at S equal to 20 what? 20 meter, right? At equal to 20 meter, what is the value of the V, right? It should be, what is the equation again? We already defined at S equal to 20 meter, we have 7.071 second, right? So you have this 0.8 T. That's the equation, by the way, right? 0.8, 7.071, right? Someone was asking, was it Joe? Maybe Joe, right? Or somebody. No, it was probably Prodi. You're asking? Or yeah. Yeah, how come we are seeing the T is second, how come we're seeing meter per second? Because you got to understand, this 0.8 here does have a unit, okay? So that's how you're going to get it. Anyway, so that's your unit. So you are going to have a velocity value of, I don't know, it's not written in my notes. 5.6? Perfect. All right, so that's my velocity. Can I box it? Now, question is, can I find the acceleration? I have these two components of the acceleration, okay? And if you may understand, this is going from left to right again, okay? So that's the consequence of that. So you have this AT. Let's do the AT first. So dV over dt. So now, if you're going to do the derivative of 0.8 t, do you know the answer of that? Anyone? It's just 0.8. Everybody agree? Meter per second square. Same thing comes up here again. How to come up with the unit for 0.8? Because there's the SI base unit, and then AN, which V square. What? V square over rho, right? What is my V value then? 5.6. What is my rho? Anyone? Is it 50? And what is the value that you will be getting then? I don't have the value for some reason, whatever reason, I don't know. Do I? Oh, I do. Is it like 0.64?
Yes.
Meter per second square. Now, I have to do the final thing, the Pythagorean. AN square, AT square. Okay. What is the value that you are getting? 0.64 square, 0.8 square, meter per second square, right? So the A should be equal to 1.02. Is that the value everybody got? For some reason, I don't have the value here. I don't know why. Okay. Does it look too scary? No. This is solvable. I'm just trying to see on my notes if I have the answer. Yep, I do have 1.02. Perfect. So now I'm confident. Calculation that everybody did was correct. Okay. I have one final problem. You see, I still have more than 15 minutes. So we are actually prepared for the exam. Everyone understand these two problems? At least we are prepared. So the final question. Final question. Okay, I'm seeing some of you are taking notes. Take your notes. Finish the notes. Let me know when you're done. Okay. You have access on this video lecture uploaded after every lecture, YouTube video. Okay. The only unfortunate thing is you don't have access of this one note. I explained at the beginning of the semester. But I was going to laugh, which I shouldn't. If you want to
if you wanna, get a printout from the screenshot somehow from the YouTube, it is okay. It's up to you. Like there is no control of mine, so you can say that this is something if you'd like to do, you can do it. That is too much of work though. Getting a snapshot and everything. It's much easier to write it instead.
All right. Let me know when you guys are done. Done? Okay. So should I move on? You have these two fighter planes, A and B, are flying at the same altitude. I'll try to give this type of question, the relative velocity question, in take home. If I'm gonna decide on take home, okay? Because relative velocity question could be puzzling for you in the exam. I understand that. Most likely you would be seeing like this straightforward question, like maybe some short question, very short question as well, okay, in the exam, not necessarily only the math. But if it is like a little bit challenging, maybe I'm gonna give it a take home. Just wanna give you a heads up, okay? So there's two planes, A and B are flying at the same altitude. If their velocities VA and VB are given such that the angle between the straight line course angle is 60 degrees. Two velocities are given for these two planes. Okay, determine the velocity of plane B with respect to plane A. Okay, this one is a very straightforward problem. So you can extend this line and put kind of x and y axis. I'm going to take out everything, so not to make too much of crowded here. So say like I have this x axis here, and say like I have this y axis here. So I have this x and y axis. The reason I'm doing that, I can extend this line, right? So this is my BV. Everybody agree? Now, can anyone tell me what is this angle? 30. Thank you. Why? Because if this one is 60, this one is 60. Okay? All right, so I do have those. Now, what I'm doing here, what would be the technique to solve this problem? Remember, in one problem we did that. We find the components of x and y for the velocity. Okay, so we'll be using that technique. So in other words, you'll be doing this. So we're going to find the x and y component of VA and VB. So that would be our technique, right? So to find the x and y component, so let's focus on BV first. So BV has BB cos 30 I BB sin 30 J. How many of you understand this? Everyone? No exception? Okay, can I write this VA with negative 500 J, and both of them has a unit of kilometer per hour. How many of you understand this? The second one, if you understand the first one, the second one would be piece of cake, right? All I did, like those two velocities that I have, I just make it x and y component, and the other thing is like I make sure this velocity of VV comes to the first quadrant. In other words, the angle 60 that was given before, actually we found out with x-axis this is actually 30, okay, for VV, the velocity of plane B. So that is the trickiest part here to understand. That's why you may do mistake, okay, in exam. Okay, so now that we have these two velocities, what we're going to do? All you need to do here, just write this equation. Now, if the problem is that much straightforward, where you are trying to find the velocity of plane B with respect to plane A, which is BV minus BA, if it is like that much straightforward, you may be expecting this kind of question in exam. If it is not that straightforward, like the last class, remember, we did a little bit complex problem in relative velocities, then you may be seeing those in take home. Okay. So now that I wrote the equation, can you solve it? Now you guys remember, anytime you have a, right Joe, anytime you have a line on the top of any velocity or acceleration or position, what is it refers to? So it's a vector, right? So vector does have like these three components, x, y, and z, if you are dealing with the Cartesian. Now we have only two axes, right? X and y means I and j. What is I and j again? These are unit vectors, right? I, j, k, unit vectors. All right. So now that we have that, what we got to do is like just simply plug the values, okay? And then when I'm saying plugging the values, you got to find those values, right? So you have this 700 cos 30, okay? I plus, what is the next one? 700 sine 30 j, and then 500 j. I'm skipping the unit for now, but you know the units are same. All right. So then, what is this 700 cos 30? What is the value? I don't have the exact numeric value.
606.22.
What's the value again?
606.22.
Okay. What is the 700 sine? Is it like 350?
Yes.
And then 500 means 800? You guys agree? All right. So that's the velocity of B with respect to A. What does it really mean? It means as if like, okay, as if like you are sitting on 10B, right? And 10B is flying on air with some speed with an angle with plane A. Plane A is also flying, right? So now this BBA or the velocity of B with respect to A is referring to the relative velocity or the passenger. We're gonna feel like that's the velocity, okay, of BB with respect to A. Is it clear to everyone? All right. Now, what are you gonna do with this I and j velocity? Nothing. It doesn't make any sense, right? It doesn't give you any real value. To get a real value, what are we gonna do usually? Pythagorean, right? So that's what, like, to get the magnitude, right? This is the vector. So to get the magnitude of this thing, you want to write it this way, VA, BVA, then you want to write it like what, 606.22, 800 square, and this is in kilometer hour, by the way. So I skip that kilometer hour here, which I should be doing it here again. And then if you're going to do the math, what's the value we're going to get? Do you have the answer though?
It's 850, right?
Yeah, it's 850. I'm sorry, extremely sorry. 850. In my notes, it's 850 as well. I don't know why I wrote 800. Okay. What is the value you got, Alyssa?
1044.
Perfect. You got it right. So it is 1044 kilometer per hour. And that's your final answer. I guess, as I said, if the exam does have this simple straightforward problem like this, you'll be expecting in class. If it's a little convoluted, it's in take home. Okay? Again, I gotta figure out something like today. Or by tomorrow morning, I'm gonna send it. Okay, Friday exam, everybody's ready?
Yes, sir.
Right. I would expect to see everybody who's going to do well. I would expect to see everybody who's going to submit the homework on time, because I said it already at the beginning of the semester. Don't delay on the homework, okay? I won't be accepting if you delay on the homework. Unless if you make an arrangement with me for whatever reason, okay? All right, I'll see you on Friday. Good luck with the exam. Okay, let me finish the recording.